the sky. We see them flying free. That's just like you and me. Everyone is lonely sometimes, but I would walk 1,000 miles to see your eyes. You are not alone, we are family. Hold me like this.
The lightning conductor. It was the American scientist Benjamin Franklin who showed that static electricity formed due to friction between the droplets of water, and the particles in rain droplets are the ones termed as lightning. The history behind this was done by Franklin with his son William, where they launched a kite made of silk handkerchief and cardwood into the thunderstorm. The metal key was attached to the end of a dimpled hamstring, which was attached to the kite, and Franklin's goal was to prove his hypothesis that lightning was an electrical phenomenon. His observation was that he observed a spark of electricity when he brought his hand near the key, confirming his hypothesis that the lightning was indeed electrical in nature. Lightning was electrical in nature. So this experiment was done in around 1752, the 1752 kite experiment by Benjamin Franklin, along with his son William. What is lightning? Lightning is a gigantic electric discharge between two oppositively charged portions of cloud, or between two charged clouds, or between a cloud and any other object on the surface of the earth. So we can see that is between two oppositively charged clouds, between the earth and the cloud, and also between the charges within the cloud. So basically there are three modes of lightning. What causes actually lightning? Within a thundercloud, many small bits of ice bump into each other as they move around in the air. This collision creates electric charges. Eventually, the whole cloud gets filled up with the electrical charges. The positive charges, or the positively charged particles, stay light and raise to the top of the cloud, and the negative charged particles get heavier and collect at the bottom of the cloud. As more and more particles become charged, they divide as positive and negative groups in the cloud. The three cases of lightning. The first one is intra-cloud lightning. This is when the power of attraction between them gets too great, in that the particles discharge their energy at each other, completing a path of electricity to travel through the air. We call this flow of electricity lightning, or for this case, intra-cloud lightning. And for the other case, if the electricity discharges between two charged clouds, then it is inter-cloud lightning, between two charged clouds. Then lastly, at times the electric discharge can take place between the cloud and the earth, and the type of discharging is called cloud to ground lightning. This type of discharge can be extremely dangerous. So the three cases, we have friction, charge redistribution, and then creation of electricity path. How does lightning strike the building? So when a negatively charged cloud passes over the building, negative charges that concentrate at the bottom of the cloud cause lightning to strike the building. And this is what happens. When this negatively charged cloud pass over the building, they induce positive charges to the house through the leader charges. Then the positively charged cloud charges on the house are attracted to the negative. They are attracted to the negative, as you can see, through the streamer. Those charges that are attracted to the negative are called the streamer. Eventually, the negative charges are neutralized, creating a path, or electric path, which is in form of electricity. And for that, if a house has no lightning conductor, it is eventually burnt by lightning. And eventually we hear thunder. Thunder is a sound that follows a flash of light and is caused by sudden expansion of the air in the path of the electrical discharge. Let's now examine how lightning conductor protects the house from the danger of lightning. In other words, the importance of lightning conductor. But before that, let's examine its parts. The lightning conductor. So it's made up of the following parts, key parts. The flat, thick strip of copper material, then we have the sharp spikes, and then lastly, we have the buried or the earthed copper plate. It is done to actually increase the contact area with the earth. So considering a charged cloud passing over the house that has a lightning conductor, negative charges are induced or are repelled to the far end of the copper plate, and positive are induced at the spikes. These positive are attracted to the cloud and neutralize all the charges on the cloud. Neutralize all the charges on the cloud. As you can see, negative charges being repelled to the far end of the earth. By so doing, the earth is safely protected from the dangers of lightning. How close is the lightning? So we are going to use the flash to bang method that's used to determine or to estimate the distance between the observer and the lightning flash. So on observing the flash, we record the time taken for you to hear the sound. And given that we know the speed of sound in air is approximately 340 meters per second squared, and from the velocity of sound being equal to distance over time, where d is the distance and t is the time taken, we use this to find the closest distance, or the distance between the observer and the lightning. So in substituting, you get the distance. So as you can see, first time you are seeing the lightning, second case you are counting the seconds, and then the last case you're calculating the distance. The rule behind this is called the 30 to 30 rule, that we use to estimate how close someone is to the lightning. When to take a shelter and after how long? So the 30 to 30 rule helps us to determine that. If the time between the flash of light and the subsequent bang is 30 seconds or less, please take appropriate shelter and remain sheltered for 30 minutes after the last thunder. Remain sheltered after the last thunder. What to do and where to go? Lightning makes every single thunderstorm a potential killer. On the other hand, however, following certain lightning safety guidelines, we can reduce the risk of this lightning or the injury. Remember, you are responsible for your personal safety and should take appropriate action when threatened by lightning. Allow me to emphasize on the last statement. Remember, you are responsible for your personal safety and should take appropriate action when threatened by lightning. Let's play this game. The game is My Life Matters. Observe the visual carefully, decide which one is the safest option and click on it. The question is, what do you do when you are in an open field during lightning? I give you 1 second, 2 seconds. That's 1, 2, 3, stop. Let's confirm our response. And the response is, if you are in an open level field, far away from the shelter, kneel on the ground immediately with your feet together. Place your hands on your knees and bend forward. Don't lie, please. Avoid being the highest point on an open area. The second game is, what do you do during lightning and you are at the poolside? 1, 2, 3, stop. The game is My Life Matters. Let's confirm our response. So the response is 1. Whenever there is a lightning, stay away from water. 2. Return to the land as quick as possible if you are on the water. And then lastly, don't stand in puddles even if you are wearing rubber boots. Game number 2. What do you do during lightning and you are on a drive? 1, 2, 3, stop. My Life Matters. Let's confirm our response. Here we go. It is safer inside a car during lightning, but don't park the car near or under trees or other tall objects which may become a path of discharge or collapse during thunderstorm. Be aware of downed power lines which may be touching your car. Game number 4. What do you do during lightning and you are on a forest trek? Please pause the video and click on the safest option. 1, 2, 3, stop. So the safest method here is, if you are trekking through a forest, seek shelter in low-lying areas under thick growth of smaller trees. Game number 3, if you are on a picnic on a riverside, you are on a picnic and you are on a riverside, what do you do? 1, 2, 3, stop. Let's confirm our response. Stay away from objects that conduct electricity. Lastly, when you are in group in the open, don't stand close to each other. Game number 3. Which is the safest place to be during thunderstorm? 1, 2, 3, stop. My Life Matters is the game. So let's confirm our response. The safest location during a thunderstorm is inside a large enclosure structure with proper plumbing and electrical wiring. If lightning strikes the building, the plumbing and the wiring will conduct the electricity more efficiently than a human body. If no buildings are available, then one can take shelter in an enclosure metal vehicle such as automobile, van, or school bus. Game number 7. If you are caught indoors during the thunderstorm, what do you do? 1, 2, 3. Stop. Now let's confirm. Before the thunderstorm strikes or hits, disconnect electrical appliances including radios, computers, and television sets. Do not touch them during the storm. Do not use electrical appliances, especially corded telephones, unless it is emergency. Do not go outside unless it's absolutely necessary. Keep away from doors, windows, and anything that will conduct electricity, such as radio, radiators, stoves, sinks, knives, and metals. Game number next. The sickle are dark and you just had thunderstorm. What is the correct thing to do? 1, 2, 3. Stop. Stay or go indoors if you hear thunder. Don't go outside unless it's absolutely necessary. Game number 9. There are only tall trees and grass here. What is the best thing to do in a thunderstorm? 1, 2, 3. Stop. My life matters. If you can't find shelter, avoid the tallest object in the area. If only isolated trees are nearby, your best protection is to crouch on the open. Keep twice as away from the isolated trees as the tree is as high. Which of these is safest during thunderstorm? 1, 2, 3. Stop. Let's confirm our response. My life matters. Stay indoors. Swimming a golf club or holding an umbrella or fishing rod can make you the tallest object and the target to the lightning. Thank you so much. Well, thank you so much for listening. Thank you so much for watching. I wish you all the best. Kindly take care of yourselves. May God bless you as we share this knowledge, as we stay as a family. Of course, we are united. Thank you so much. I love you. Bye bye.